and good afternoon, everyone. My name is Giray Aktan, and I am the Associate Chair for Graduate Studies at the Department of Mathematics at FSU. I want to start with thanking our speakers for taking place in today's panel on data science, and our math faculty, Dr. Bertram and Dr. Needham, for participating in the Q&A session at the end of the panel. And thanks to all of you who have connected to listen to our panel this afternoon. Data science is an interdisciplinary field that brings together mathematics and computing, statistics and computer science. It's a rapidly growing field encompassing many sectors of the economy, including technology, information, financial services, public health, airline and auto industries. And many surveys indicate a significant shortfall of data scientists in the near future. To address this shortfall, many universities started graduate and undergraduate programs in data science in recent years. At FSU, we are starting a new interdisciplinary master's degree in data science next fall, in fall 2021. The degree has 4 majors. A student can pursue the master's degree in data science with a major in mathematics, statistics, computer science, or scientific computing. And I am going to put a link on the chat box to the degree, data science degree with major in mathematics. And if you are interested, you can visit our webpage. So let me just do that. Okay. Now, today's panel features 7 alumni of the mathematics department. Our speakers received master's and doctoral degrees in financial math, biomath, and applied and computational math. For those who are not familiar with our graduate programs, let me just comment that in our department, we have 4 different graduate areas, and they are pure mathematics, applied and computational mathematics, financial math, and biomath. The recently established data science program in math major is our 5th graduate area. So let me say a few things about the structure of today's panel. Our speakers, first let me tell you who our speakers are. They will give a short introduction, but the names of our speakers are Orhan Akal, Sardar Gellat, Fan Fei, Díaz-Martínez, Manan Shah, Chuping Zhu, and Heting Yan. And each speaker will take a few minutes to talk about their work in data science and how their training in mathematics has helped them as data scientists. Now, please, as you have questions, feel free to put your questions in the chat box, and I will read your questions at the end of the talks. And now I'm gonna turn the floor over to our first speaker, who is Orhan Akal. Orhan, it's all yours now.
Thank you, Dr. Aktan. Hi, everyone. My name is Orhan. I have graduated from FSU Applied and Computational Mathematics PhD program last summer. And I have been working as machine learning scientist in Boston-based startup company called Overjet AI. What we deal with is we deal with dental x-rays, and we do diagnosis on the dental x-rays, and we do approve or deny insurance claims given the dental x-rays of the patient. So what sort of math that I'm using in my field is essentially, what I'm doing is essentially deep learning, which is subsection of machine learning. Nowadays it's like it became really another avenue. But it's essentially like part of machine learning, which is part of the data science umbrella, or however you put it. And the math that we are using, if you are a practitioner, you don't necessarily need to know most of the math. You can, because most of them are already like predefined. The toolboxes that we are using, like PyTorch or TensorFlow or Keras, you might have heard of them. The math behind the scene is already there. So in order to start anything new, you don't necessarily need to know too much of the math. However, without knowing the in-depth knowledge of the math that we are using, you cannot go beyond being a practitioner, because that means you cannot do anything that is sophisticated, that is challenging. The problems that you can only handle without knowing math would be only easy to solve problems that are already addressed, and you just plug and play and you get the results tested. However, that's not what we really look for, because given that like Google AutoML is sort of doing that, like you put in the data, Google AutoML will give you a result within 5-6 hours or whatever, but it will be at a certain point of accuracy level. However, when we look for a candidate, we are looking for something that will go beyond that. And for that, you might need to restructure your architecture, deep learning architecture, and that requires understanding of the concept that goes behind the scene. Or you might need to define a nil loss function that requires math understanding, math knowledge, as well as what's really failing behind the scene, what's really failing like in the black box of the deep learning. So for that reason, in many aspects of my job, I do use math, whether implicitly or explicitly, but whenever I need to do something, whenever I'm dealing with very complicated problem, I really need to delve into to the mathematical concept. Yeah, and one of the questions was what we really look for, what the candidates, what the data scientists should be working on to improve is, yeah, your coursework is really important, but that is not enough in the sense that your expertise, your knowledge should go definitely beyond the coursework. That could be Kaggle exercise, Kaggle experiments, like there are Kaggle challenges, that there are data sets, there are problems that you can work on, or let it be internships that is really necessary. And like that sort of experience really help, as well as depending on the company that you're applying for is you might need to know infrastructure, like even if in my case, I'm working for a startup and only less than 10% of my job is really model training, developing models. The rest would be getting the data in the right format and then putting my model into production, testing it, getting agreement from the clinicians, and then putting in the cloud function. This sort of infrastructure that I really need to work on. But you might not necessarily need to work on this if you're working for a big company. Then they have their own infrastructure team, their engineering team. That may not necessarily be the case, but again, depending on the job that you're applying, yes, it would be a necessity. And yeah, I guess that's about enough for my time, I guess. So I will give it back to you, Dr. Akal.
Okay, well, thank you very much, Orhan. Thanks for your talk.
Sure.
And well, next I'm going to introduce Serdar.
Hey, Dr. Akal. It's good to see you.
See you too.
Hi, everyone. My name is Sardar Gellat, and I have graduated from biomath program in 2018. And since then, I have been working in the industry. I started as a data scientist at Liberty Mutual Insurance, and I was there for 2.5 years. And in my last role over there, I was leading a team of researchers, both from Liberty and from MIT CSAIL, for some NLP projects. And for the last 6-7 months, I have joined a startup. It's called Meadows. And over there, I have been doing NLP work. That is kind of like my specialization at this moment. It has nothing to do with my graduate program at all. So it's a totally new field for me for the last few years, I would say. And yeah, right now I am building NLP solutions to our clients, whether it be understanding the email messages that they are receiving from their customers, or extracting information from those messages, or understanding some of the emotions that the customers might have. So this type of the works that I have been currently doing. And in terms of like how math sits in my day-to-day work, or like my like career so far, I would say like if I were to say just like with one word, I would say like math gives confidence, basically. Like the more math you know, like the more confident you become. And in my previous role or in my current role, like I'm not afraid of taking any challenges or like any new, like trying out any new algorithms or like building out brand new algorithms, basically. So like knowing math helps a lot. So like data science, as Dr. Akal mentioned, is an interdisciplinary field, and it consists of like computer science, statistics, math. But among all these three, like math stands out in terms of understanding the whys and hows of like algorithms, like why an algorithm would work in data X versus data Y. Like why is it going to work better in that type of data? Because like when we are talking about machine learning, it's all about optimization, basically. So how optimization is going to work for like different distributed data versus another type of data. So it's all about like understanding the behind the scenes of machine learning algorithms, I would say, like, which is quite rare today. And it comes handy in many different situations, because again, like you can develop your own algorithms, like if needed. But if you lack that knowledge, you'll be just like dependent on the tools or the solutions that are out there. So that's kind of, I would say, what distinguishes math from other disciplines when it comes to machine learning world, data science world. And that should be all on my end. And well, as a side job, I do teach machine learning, deep learning courses that are like for postgraduate programs offered by MIT and UT Austin. So that's kind of like what I have been up to. It's good to see you all.
Thank you, Serdar. I'm happy to learn that you're teaching those courses. Maybe I'll be your student soon.
Yeah, I do have lots of students from different backgrounds, from different professions. Yeah, why not?
Okay, good. Okay, well, our next speaker, Fei Fan.
Okay, good afternoon, everyone. This is Fan Fei. I graduated from financial math program back to 2012, 9 years ago. And after I graduated, I was initially hired as a software engineer, and then later on, there was an opportunity in the same company, under the analytics department. So because of my data engineer background and experience, of course, also my mathematics background, and I joined the different analytics team, right? And that's a new team created to focus on the feature development. That's one step in this data science pipeline, right? So that's a new team focused on this piece. So, and later on, 2 years later, I was promoted as a manager on that team. So right now I'm managing that small team with 5 direct reports. So this company, the company I'm working on is LexisNexis. This is a data service company. We are providing data services to to the insurance carriers, like for this whole insurance industry. So our products covers auto, property, life, health. These are main business lines we are supporting. So you can imagine that we are getting lots of data, and that's truly a big data platform we are dealing with. We need to process terabytes of level of data, and it's billions of records from different data sources. We have to combine the information together, extract data insights, and then develop products from all this data source we have. So one important thing about the mathematics, I think, is to train the logical thinkings, right? Believe it or not, in this department or in this big analytics department, at least I know we have at least 10 folks holding the math background degrees. Some of them, they're just like bachelor degree. Some of them are in master or doctoral degree. So they all have very great performance in this team, in this analytics team. So I think that's very, very important trainings I got in the math program. Another very important skill set in my mind is the communication and the presentation skills, right? So I still remember one course hosted by Dr. Ogden several years ago. Not sure if we still have that, but we had to pick up a topic in that course, right? And then do our own homework, research, exercise. And then we came up with a presentation to introduce to our classmates what we have done, and of course, the outputs as well. So we have to do exactly the same thing in the company with our co-workers, with our internal or external customers, right? So these are also very important skill sets I learned in the program, this financial math program. So I think as a few speakers, they just mentioned, data science is overlap industry among business SQ, I'm sorry, the business acumen, statistics skills, and the coding background, coding skills. So talk about the skill sets you can be prepared. It's very hard to say at this moment because the skill sets is changing with time goes on. If I think of the skill sets or the languages we are using 20 years ago, the most popular statistic tool was SAS, right? And later on, people are switching to R. And now we are using, most of them, we are using Python and deep learning, neural network, cloud are the buzzwords now. So the only thing that is constant is change. So I go back to the students when you apply for a job. I would say the trainings, the way of thinking, that's very important to get an internship, right? That will start your career. Yep. And also another thing, I always challenge my direct reports or the team members, which is think of how to improve your procedures, the daily work you are doing with. If we think of the whole data science pipeline, right? We need to obtain the data and do some data screening, scrubbing and cleaning, and then do the data mining, visualization. Then we need to develop the data features, create the model, and then we can interpret the new data and predict the future, right? So think of all these steps in this data mining or data analytics pipeline. What we can do to improve any little piece, step by step. This is probably also a very important way to think of the work, or and also something nice you can put it into your resume, right, when you look for a job. So yeah, I think that's pretty much what I like to share with the team. So I give this back to Dr. Ogden.
Thank you, Fan. Thanks for this great talk. And I think we still have that course in which you have to do some research and then prepare a talk with a team member. Okay, well, this is great. This is going great so far. Well, our next speaker, Diego.
Thank you very much, Dr. Ogden, and hi, everyone. So a little bit about my background. I work with Professor Washington Mio for my doctorate degree in mathematics at FSU. We worked on spectral geometry and applications to statistics. And now I graduated in 2016, so I've been working for 5 years already in a company called Clarios. Maybe the name doesn't ring a bell to you guys, but we make batteries. We make 1/3 of the batteries, lead acid batteries in the world for vehicles, cars, trucks, etc. So my job there is sort of a hybrid of different things. I work with manufacturing data. I work with quality data. I also work with data that comes from lab testing. So we test batteries to determine their performance to different applications of the batteries, and also in the battery design process. And also I work on the later side of the life of the battery, doing survival analysis, actuarial things. So for example, estimating life expectancy of batteries. And these estimations are used to project future sales, warranties, and other types of strategic purposes. And one of the interesting things about working there is, of course, there's a lot of data, but it's not that much data as to use deep learning methods, for example. So I use other types of methods. It's more about inferential statistics. But I also do some machine learning, for example, in the manufacturing process. I've developed some tools to help engineers understand the manufacturing data and can debug them. Also, in the design process, we do designs of experiments. So we have to do, calculations about how many samples do we need to estimate the effect that certain design change can have in the performance of the battery according to certain standard metrics of battery performance. So it's a little bit of everything. So I'm very happy to be working on all these different projects. There's always something to do there. So going into which tools do I use, it's very similar to what other people use. So I use Python, MATLAB, SQL a lot. There's a lot of databases that have the data that are in SQL. And also I create tools that are used by engineers to understand their data. And also there's some machine learning in the background to help them understand warnings of the signals that come from the different manufacturing processes. So for those cases, I use Azure, Power BI, Power Apps, Power Automate to release these tools that they can be used and shared by all the different engineers in the organization. So about the importance of math, I think some of the people before me have already explained some things I'm going to say, but it's important to know math so you can understand all the different tools that you could use to approach certain problem or certain challenge in your company. And also it's important to understand which is the most appropriate tool you would like to use or you will use to approach a particular problem. Also, in my case, math is important to understand different physical phenomena like electrochemical reactions that happen in the battery. And these in turn are helpful in machine learning because understanding the physical phenomena through mathematical equations helps you create relevant features that you will use in some machine learning application. So there's a lot of modeling in my job, but also there's different things. So for example, we are in certain projects, we are implementing algorithms in the BMS. The BMS is the battery management system that it's included in modern vehicles. And when you implement algorithms like that, there's always sources of error due to measurements, right? The sensors have measurement errors. So you have to create algorithms that are accurate enough to the industry standards. So in that case, tools like error analysis from numerical analysis come in handy to create these algorithms. So that's pretty much what I have for today. Thank you.
Thank you, Diego. Are any of these batteries used for self-driving cars?
I can't talk about it. There's a lot of projects that I can't talk about, but we are working with Tesla in another OEs in some particular applications that may be for self-driving cars.
Okay, thank you. I will be talking to you in private later, Diego. All right.
Sure. I can give you a free battery if you need one.
I'm joking. Okay. Well, thanks, Diego. And now our next speaker is Baran Shah.
Hi, thank you. My name is Manan Shah. I graduated from the PhD program at FSU in 2008. I worked under Dr. Octon. And before I started the PhD, I was working in finance for a few years in commercial real estate. And then I realized I don't know enough of anything and I need to come back to graduate school. And this is where the journey began, the second journey, if you would. And after if you know, in 2008, there was the financial crisis. So nobody wanted to hire new PhDs in financial mathematics in 2008. And so at that point, I had to figure out what to do. And luckily enough, I was able to just get enough consulting business to keep myself fed. And after about a year and a half of just consulting with various folks, boutique investment shops and CDO shops, and even just a little bit of tutoring on the side, I got a job in the regulatory gaming world where the mathematics there was heavy on the combinatorics, heavy on the statistics, heavy on discrete mathematics in general. And it was about finding betting strategies to make sure that when a new game came out onto the casino floor, people can't beat the game by employing clever betting strategies. Or if there's a slot machine that is going to come out onto the game floor, it's not a broken game, that it actually meets regulatory requirements. So all of the math there wasn't your classical, machine learning data science, but it was very complex combinatorics, statistics, working with regulators, working with the rules and designs of the game, and getting those things programmed. And having a team there of about 25 to 30 to operate over, we were able to basically service the global gaming market. And that was a fun experience. But eventually I missed the consulting work. So I went back into consulting for a few years. And from that, I got picked up again by one of my clients, but this time it was in social casino gaming. And social casino gaming basically means it's a mobile app. People download the mobile app, they play a casino game for fun. They pay me real money into playing the game for fun, but they're not getting real money out of it. So now you're not burdened by the regulatory constraints anymore. And what you're doing is you're designing games. And the design of those games requires sort of this mathematical thinking about what will make a game entertaining, what will make a game not entertaining, which games will monetize the best. And when you start thinking about your users, you start thinking about clustering those users. Which ones are your heavy spenders? Which ones are your high risk players? Which ones are your conservative players? Which users actually have this very low price point that they're willing to make an in-app purchase, versus which users will make that $100 purchase on the first day and then keep paying $100 at a time. And you see that what we often learn in our coursework, especially in statistics, we work with normal distributions and these nicely defined ones. User behaviors, they tend to get very, very skewed. So you end up finding out that you've got, I don't know, 1 million users, out of which 2% pay you, out of those 2%, 0.1% make up like 90% of your revenue. And so now you're zooming into this very, very small category of players that you're catering this game to, but you don't want to lose that large user base, because if you can start to monetize them over time, you can continue to grow a larger app. So that was a fun experience, and there the data science work starts to pay off, because now you are trying to profile users with minimal information about them and what you can get from their app or from whatever social profiles they've linked. After that, I moved into MarTech, which was interesting, but not interesting enough to talk about in the limited time here. And then it was video ad tech, where we worked on real-time bidding. So if you saw like a video ad following you around the internet, we probably had something to do with that. And it was, again, about profiling users, figuring out, well, are they going to click on this thing or not click on it? And can we get them to the store, and can we get them to purchase the thing that we want them to purchase? And that involves, a lot of A/B testing out your algorithms, testing out whether or not you're going to whether or not, it's worth paying $50 for this user or not, or should you pay 10 cents for the user? And now I'm at Vimeo. It's a video tech company, and here, I run my title is VP of Data Analytics, and we have a lot of data science work to do, and that boils down to like churn prediction of our users and purchase predictions, and can we make the product a better product for certain sets of users? Who are our users? How do we find out internally for ourselves our financial forecasts? How do we know which sets of product actions that users take that would make things a better experience for them? And in doing so, the types of mathematics you run into aren't like the mathematics that we're used to, where you have a nicely defined function. You're always working with data and you're trying to discover the function here. So when we start thinking about, the types of skills that you need outside of all the technical skills that our panelists so far have spoken about, I would say, what's really important, especially for me when I'm hiring candidates, I'm really looking for people who can communicate a story. Can they actually give me impact of work? You'll often see on resumes, implemented this algorithm and implemented that thing and support vector machines and what have you, but nobody can tell me what was the impact of this? Did you boost revenue by 5%? Did you save your users by 3%? That's the sort of thing that, I think we have to get to when we speak to leadership. And that's where I think really the impact of a data science team comes into play. In the 15 seconds left here, I'd say that if you're really thinking about going into data science and doing that work when you are looking for a job, my biggest piece of advice would be figure out how well organized the organization is for a data science position. In smaller companies, as Orhan mentioned, you're going to be doing a lot of data pulling, data gathering, and then some modeling. In larger companies, you have structure set up, but make sure that they have data science problems to answer, and that you're not just pulling together reports and dashboards if that's not what you're interested in. Thank you.
Thank you, Manan. Before I ever watch a video again on internet, I will check it with you. Okay, well, our next speaker is Chuping Zhu.
Hi, hello everyone. My name is Chuping. I graduated from FSU Biomass program in 2015. I worked with Dr. Washington Mill and also spent enough time in Dr. Liu's lab. Good to see you too. My first job after grad school was at Intel as a data scientist to do revenue forecasting. And then after 2 years, I moved to Amazon. So currently I'm a senior applied scientist at Amazon. So my current job is kind of in between of science and engineering. The core job function is to bring in innovative solutions, and the solution need to be feasible in terms of large scale production system, and need to satisfy the requirements of different things like latency, need to be stable. So for me, I'm excited about this job because my interest is really about bringing stuff into production and bringing the stuff in front of my customers. So in the past 4 or 5 years, my projects has been in dynamic pricing, recommendation system, quantify advertisement effectiveness, and then of course predictive modelings. For me, I do think mathematics is super important. It's the fundamental of all the machine learning like algorithms. In my current job, it's pretty rare. Like I can find an off-shelf solution that can works well, that can satisfy all the requirements I want the algorithm to be. So most of the time, I need to have deeper understanding of different algorithms and understand why people design things in a certain way, and understand the pro and the cons from different things. More like take the ideas and take the combination of different ideas to satisfy the thing I want to do. So in that sense, mathematics really helped me to understand what's going on in all sort of algorithms. The other thing I will say, mathematics also helped me to learn things faster. A lot of things I'm doing right now, I don't have like proper training in terms of school. And I honestly do not think a person can be trained 100% to do whatever they need to do in their job. So for me, I learned to do causal inference in my current job. I learned to do how to do reinforcement learning in my current job. So the solid background of mathematics really helped me to learn things faster. I do think this one will also help me in the future of my career. Just to think about how the domain is changing, like how many new algorithms is coming up. I do think like continuous learning gonna be part of my career. I need to learn new stuff along the way. And also, I think the training in mathematics really helped me in terms of logical thinking. So as we grow into scientist role, one technical aspect is one thing. We need to understand algorithms. We need to like do hands-on stuff about scripting or coding. But in my current interviewing or hiring events, I do feel some of the students just out of school. I don't want to give two suggestions. One is to look ahead of the technical skill or the technical problem. Most of the time in company or in real scenario, you're not given like I need you to solve a regression problem, or I need you solve a classification problem. You were never given this kind of thing. You are looking at a business problem, how to bridge the business problem to a scientific problem. That's the thing we need to do most of the time. It is the first step. And then I also recommend us to look after you finish your data analysis, you finish your like code, you finish running all the things, you get all the metrics. Like I think some of the panelists mentioned how you communicate and what are the insights you can extract from the analysis. Mostly like what are the actions different team or the company can take to take advantage from all the analysis you have done. That's the thing I see. Maybe that's not very common in fresh, like out of school students. So on top of this, I think for everybody interested in data science, there's of course, look into the technical skills, but also look into the communication skills to get from business problem to technical problem to communicate the results. Also be prepared to keep learning new stuff and keep challenging yourself. I think that's pretty much all from me.
Thank you, Xuping. I think your final words were really important. Keep challenging yourself and keep learning. And I think it applies to all of us. Okay, well, our final speaker is Heting Yan.
Hi, everyone. My name is Heting. I graduated at 2019. I was in the financial maths track. When I started the track, I really want to go to Wall Street. I was really interested in finance, but I did 2 summer internship at Yahoo, working on advertising, and then I start thinking like, machine learning is also interesting. So I learned it by myself, and then now I'm working at Microsoft. I was working at the Bing search, doing advertising. So when you like search something in Bing, you might find on the top there are some advertise, and then you will see usually one link. There are 4 or 6 short links below it. that's what I'm doing. I'm trying to trick you with the most attractive title and let you to click on it. That's how the most of the big companies make money, like Google, Facebook, Microsoft, Amazon also do it. That's what I'm doing. And usually when I do this, we are doing machine learning modeling. We will start collect data and then train clean the data, train model, and then evaluate it, and then test it, put it in production system. What I think the math is helpful here is that, as Chupin said, you need to formulate those business problem into a mathematical problem, or some problem that people can solve it by programming. I think a lot of classmates went to different areas, and we all need to understand the business behind those areas and then formulate it into a problem that we can solve. And when you solve those problems, you don't have to use machine learning. You can, as in our company, we can do it by any method. It doesn't have to be machine learning. Machine learning is helpful or popular is because in the digital advertising, we have a lot of data. If in some other area you don't have a lot of data, if you come up with a great model that definitely can beat those machine learning algorithms. Another thing is that there's always a lot of problem that's not in the book. Like you cannot expect let's say you finish this program in FSU or in any school, you know all the solutions to all kinds of problems in a real company. That's not going to happen. When you go to in the school, we are learning a lot of fundamental things, and when you go to school, there are always always harder or more complicated than you think. For example, if you know a little bit about data science or machine learning, like when you try to teach a model something, the target is always fixed. If it's a cat, it's always a cat. If it's a dog, it's always a dog. But when you do advertising, the target is changing. Let's say today people are thinking about air condition. Tomorrow maybe people are focusing on election. This target is always changing. How do you handle that? There's no such a thing in the book. You always have a lot to learn. So mathematics is a very good, if you're good at mathematics, it's good help. It can help you to learn a lot of things faster. One more thing is I think if it's 10 years ago, if you can build something, make something to work, that would be great. But now, when you do something, there's always something already in there. You need to improve it. So you need to understand how it works and then make improvements. So you actually need to understand it very well. And it could be like engineering problem, it could be statistical problem. So you will need something like logical thinking or anything that can help you to understand those things very well and then make your improvements. And that's also why mathematics is also helpful. Thank you.
Thank you, Heteng. Thanks to all of our speakers. The first part of our panel is over. Now we're going to have our Q&A session. So if there are any questions to our panel speakers or to our faculty, Richard Bertram and Tom Needham, please put that in the chat box. And there is actually a question from Jingdun Kai that I will read. Which data-related fields are most promising in the future? Computer vision, NLP, or recommendation system?
I can start. I don't have a good answer and I cannot forecast the future. I probably will say, let's say, given all the development of auto ML, the more human knowledge you're involved into stuff, or like just think about how easy auto ML can do that stuff for you. If that's super easy, I don't think that's a super promising field of things. And then for the 3 examples gave, I don't think maybe we should not think them like individually, rather than thinking them like, say, what's the goal of doing that, and whether the goal really matters. And is that possible to combine all the things together to achieve the final goal, or you have any very good solution to help achieving the final goal rather than going through like computer vision type of things? So I would recommend start from that line. Yeah, Serdar, I would turn to you. I gave not a very good answer to this question.
That's okay. That's it was pretty good. I was gonna add this. So in terms of the job opportunities, well, that's kind of like the ultimate goal here, like to get into a job and find a kind of like an enjoyable job, not just like a job. I would say like all these 3 areas quite like popular these days, like both computer vision, NLP, and recommendation system. In terms of like the job opportunities, I would say NLP and recommendation systems are kind of like one step ahead of the computer vision, not because the field is not like good or like popular. It's because of the areas of application. It's because of the availability of data. Because in NLP, like there are like hexabytes of data like generated every day, and that can be solved like in many different ways, or like that can solve like many different business problems. So it's not like one field is better than the other. It's just like how widely that field is being kind of like is solving problems in the industry today. So NLP is solving like a lot of problems. And yesterday I was reading this article from Forbes. It's about like 50 AI companies, and 50 promising AI companies in the US. And I would say like 20, 30 of them, they were like about NLP, and only like 5 to 10 of them, they were about computer vision. And that's not because, again, like these fields are kind of like one is better than the other. It's about the data availability and also the problems that can be solved with these tools.
Serdar, can I ask you, what do you think? Like, it seems as if NLP and recommendation systems generally is harder task than computer vision task, because you have many edge cases, or many like the data is not as much structured as images. Well, even the image is not well structured, but like I would say, I guess like the text data is like is worse to like harder to deal with. Is that the case?
I cannot like make direct comparison with the computer vision, because like I'm not like too familiar with the computer vision like data sets, not like the applications, but the data sets. But I would say in NLP, yes, we have like messy data sets, but they can be dealt with basically. So it's not like they sit there and we don't have solutions for. We do have solutions for all varieties of text basically. Yeah.
Okay, thank you. Let me, we have another question. Let me read that question. And this question is for Orhan. What is driving the use of MLDL in dentistry? Dentist workload, misdiagnosis, need of a second reader, fitting prosthetics?
So the issue is, when I heard this, it really shocked me. None of the dental schools in the US, including Harvard Dental School, do not teach how to diagnose in the dental school. So the dentists that you see, they learn how to diagnose once they graduate, and once they like work once they do their residence beside with a experienced dentist. And if, let's say, the dentist that he worked with is sort of old, and some of the, let's say, doesn't believe in some of the sicknesses, and then there is bone loss, and the dentist don't believe in the bone loss, or that didn't even know how to diagnose the bone loss, then couldn't diagnose it, then what ends up is patient is losing its teeth. If the dentist knew how to diagnose it, it could have saved it with the treatment. So that's like the very first drive. The second part would be like the claims that the dentists send to the insurance companies, they need to be reviewed by the clinicians as well. So the like you think about it, if an insurance company receives 100,000 claim a day, and they need to have maybe 1,000 clinicians in-house to review each claims, which has a huge cost to them, and they generally send these claims to overseas. However, that still costs them, and it takes them at least a day to respond. So there is additional cost to the companies. There is bias, definitely. There is no standard of diagnosis, and the speed. Like we can do it in real time. We can within a minute. We can give the diagnosis. We can approve or deny the claims within.
Yeah, thank you. That was really interesting. I didn't know that the diagnosis wasn't something they learned at school.
And ever since I heard of that, I'm not going to the dentist. I'm trying to find the best dentist to go to.
Okay. The next question is, I'm reading it. Does anyone see a role for traditional AI, knowledge representation and reasoning in data science? Do we have any experts in knowledge representation and reasoning?
I'm not an expert at all for that matter, but what I heard is like one of the things with the auto self-driving cars is they lack the reasoning. So they can they can find the they can get the lights, they can get the pedestrian, they can get the cars driving around, but what is this let's say there is pedestrian looking for the lights, light is green or red, and it's gonna about to go across the crosswalk. So that sort of like reasoning is still lacking, as far as I know. And because of that, like the self-driving cars are very conservative. So like they don't have that reasoning. So they just, okay, there's going to be something, if there's going to be an accident, okay, let's not move. Let's just slow down. So that's what I know. I don't know too much about it. But yeah, if we have something, we can put it in pipeline, at least for the self-driving cars, we would really make use of it.
Okay, thank you.
I want to add a little bit on the representation learning. Actually, within Amazon, we have centralized teams targeted for learning representations. And if you're interested in machine learning conference, you know there's a conference called International Conference on Representation Learning. So the goal for that is to learn some good representation, or let's say features that can be as the building blocks for so many different applications. So in that way, we can achieve better generalization. We don't need to rely on gather data for one specific task and then learn one specific task. So it's more about learning a representation. Let's say they tie to this. I would say it's not traditional representation learning or like logical thinking. It's more about a combination of this with machine learning. So they learn the fundamental features and can be used for so many different tasks. So in NLP, we do like, we typically use embeddings directly rather than like train our embedding ourselves. We use embeddings from other stuff from BERT or GPT-3, just plug in to our application and then build on top of this to learn our specific tasks. So that enable transfer learning and so many other things. I think at least in machine learning field, in the work I know, I think there's a lot of room for representation learning. Recently, there has been a lot of interest in causal representation learning. So in machine learning, we normally look at associations rather than causality. But now we want to look into causality that will enable us to have better generalization and can kind of avoid, let's say, overfitting to certain like distribution of data. So those are all like trending work in machine learning, not in the typical representation learning way, but the combination of representation and machine learning. I do think that's a great future of this. And there are so many interesting works on this. And then I know there's a recent paper from Yoshua Banjo. It's a paper called Tavos, like causal representation learning or something. That's an interesting paper. I do see a great future of this.
Can I add something to that from NLP perspective? Well, since I work in the NLP, I have like from the representation learning, and also like we are kind of like slightly moving towards like it's hard to call it like reasoning or AI reasoning, but there's still like lots of work that falls under this representation learning, or also like reasoning. One field which is called like natural language inference. And also like there's this zero-shot learning or few-shot learnings. So these are kind of like the topics that fall under the umbrella of like representation learning or reasoning. I am currently working on NLI. That's what we call like natural language inference and zero-shot learning. And I have developed some methods that can detect the emotions of like users from their text messages without any training, without any kind of like labeled data. So these are kind of like some areas that are kind of like booming basically these days.
Wow, that's very interesting. Okay, well, let me move on to the next question. I studied mathematics with economics at my first degree and currently studying masters in logistics and supply chain. How can I get involved in data science or AI?
So there's a bunch of logistics companies right now, and I'm happy to chat with anyone afterwards, that are trying to solve basically bidding problems for how to move goods from one place to another. And they're effectively just brokers that try to match truckers to routes and bid on the right amount for the route, and then see if they can find the trucking company to do it at a slightly lower price or a slightly higher price than the price that they bid, and that's their profit margin. So there is an entire industry that's just focused just on trucking itself and moving goods back and forth and the bidding process for it.
I can add something to that. Like there are many different companies, they specifically hire kind of like supply chain. That's kind of like what they call like supply chain data scientists. Like all these like online shoppers or like these online stores like Amazon, like Chewy, they hire like this type of roles. At Amazon, like it's mostly falling under the research scientist roles, but the work is like quite similar to each other. So it's there's demand on that as well.
Yeah, maybe I can add a little bit just from Amazon point of view. We hire scientists in all kinds of roles. And for the background you mentioned, you have background in econ, you have background in mathematics, you have background in supply chain and optimization. That's a very good fit for Amazon certain part of the business. We have a huge division doing logistics. And just one way to think about this, maybe I can give a specific example. Let's say, if Amazon ship certain stuff for seller, we charge seller for a certain fee. So what's the best fee to charge for that seller? In that sense, you have some question around mathematics, and you have some question about optimization. And there's also some aspect of econ in this. Let's say whether you value short-term benefits or you value the seller's life value. you get the business from the seller, earn the seller's trust, the seller will stay on Amazon platform, and the seller can increase Amazon's like diversity of products. So there are so many different questions in this one specific examples. I do see there's a good fit in so many different groups in Amazon.
Yeah, I can't agree more with Kim on this particular question, because I say the data science roles or openings occurs on all different industry and the companies, right? They need the people with, I think the one big thing in data science role is the domain knowledge, how you understand this industry or this particular area. That's very critical to perform the data analytics work. So I think with this background, you can find some combination or overlap with the company needs in this area.
Okay, thank you. Well, there is one more question in my chat box. And the question is, I heard data scientists spend 90% of their time to do data cleaning. Could you comment on that in your position?
I can talk about a little bit. It mostly depends on the company. Like if you're working on a small company or startup company, it doesn't matter what role you are, you have to do everything. But if you're working on a big company, there usually some like engineering team handling all the data, like they already organize all the data nicely to you. But in my team, in my company, I'm working on a big company, Microsoft, but our team does not have engineer. So I need to grab data by myself. I do some cleaning, but since the company is already like, a lot of people using the same data, so we know which data is, which column is useful, which column is useless. So it's not that hard for us to pick those useful columns. And also it depends on if we're working on like, let's say NLP or computer vision. Usually those two don't have much data, so you don't need to worry about the cleaning data.
Yeah, and I want to add from my personal experience in my company. So when I started 5 years ago, a lot of the lab testing data was stored in Excel files in someone's computer, and it was very disorganized. But at that same point, a system was implemented to ingest all the data and put it in a database. And right now, 5 years later, we are seeing the good things about putting the data in, let's say, robust sources, because we are now able to do many things like allocate lab resources. But nevertheless, there's always the need to clean data. So for example, sensor data, as I was mentioning before, there's always noise in it, right? And there are bugs in the ingestion of the data from the sensor to the database. So there's always the need to do certain type of cleaning before moving forward to do any machine learning application. So what they say is true. Data wrangling is a big part of data scientist job, and sometimes it's easier, sometimes it's harder. And of course, it depends, as other people have said before, on the company and how, which importance do they give to having robust places to store their data.
Well, one more thing I want to add, sometimes a little bit of noise is okay. Like if it really happens, like the system won't be correct 100 times. So maybe there's some bug and in a small chance, but your model also need to be able to handle it. So sometimes a little bit noise is okay.
Yeah, and then I think, you know, the point that I want to make on just cleaning data versus having bad data that actually needs sanitization, you know, you can have a pristine data set where all the data points are correct, but for the problem that you're trying to solve or the question that you're trying to answer, you will still have to go through some level of data chopping and data cleaning and extraction of relevant data points, especially when you're working on data that involves human behavior, because you will have weird outlier behaviors. When you're in freemium type of products, especially in the gaming world, we had just weird behaviors where you will have a player, you know, playing for 24 hours a day, somehow, some way. And that's probably not what you need in your model, because if you're just even trying to do something very simple, like a simple type of regression where you have a least squares type of error metric, it's going to kill it. So you will have to set boundaries. You will have to set, you know, reasonable guardrails as to like how to apply your methods. And to the point on having a little bit of noise, if your model can't handle the noise, then maybe it wasn't a good model, because in practice, you will have to work with the noise that already exists.
Yeah, I agree with that. But of course, you always need to look at the data and be aware of all those sources of error so you know how to control them. So that's part of the data wrangling. You can't just go blind and start your machine learning application without seeing if there's potential noise in the data. Because if there's noise in the data, you might as well need to control it before your conclusions are completely biased because of that.
Yeah, exactly. In my position, we are actually using the insurance data, right? The insurance data actually contributed by the carriers, like the insurance company, State Farm, Allstate. We believe these data are great data, good data, because they are the claim data. You know, even like some consumers, they file a claim. The carriers, the insurance company, contributed these records to us. So we believe the data has a good quality, and also we have the data engineer team to load this data from all the different carriers to our database, right? They have their scrub rules and cleaning rules, and build the we call it base file or database. We still have this type of data quality problem, believe it or not. Even the contributors, they are so, you know, reliable and trusted. So yeah, so I would say I'm tending to agree with these statements that we still have to do lots of data manipulation work when we work on a particular projects. Just need to consider, you know, first of all, we need to consider the objective of these efforts, what goal or what targets we are trying to predict, right? We need to extract the data features and also do the data cleaning to make sure the data is good for this objective. So yeah, in most of the projects, I think that's kind of true. 80 to 90% of the work is the data manipulation work to link the information together from different data sources, to the data cleaning, drop whatever the information we don't need or feel some null values, you know, handle those type of missing value and dirty data. Yeah, that's part of I would say take most of the time. Regarding the model training, most of us, we already leverage some existing functions or modules developed there. So yeah, so I'm tending to agree with these statements.
Okay, thank you. I think we are coming close to the end of our panel, and slowly wrap things up. I have two final questions I'm gonna read. Before I read those questions, Manan, I want to quickly ask if the person who was playing 24 hours a day, I hope that wasn't my son, you know? No, okay, good. If that happens, let me know. All right, so two more questions. Here's the first one. If the panelists could tell us what courses they wish they had taken and what courses they wish they were offered, and what kinds of tools they use for their daily tasks.
So I don't know if there is really a course for that. I wish I could have taken a course with domain adaptation and uncertainty quantification. Those are the fields that, like, those are essentially open research topics. And in my field, in the medical imaging domain, those are really, like, domain adaptation is really important. And in general, for the all ML thing, ML pipeline, ML models, uncertainty quantification is really, really important, because the issue with the deep learning is they are overconfident. The models don't know when they don't know it. So they will always be, most of the time, will be confident. And if they fail, they will still be confident. And that's essentially tricking us. So one way is, so that's like, for that, we need to do uncertainty quantification. And I don't have experience with that, and I'm trying to learn it. Yeah, I guess that's about me.
I want to say that you will actually need to read a lot of papers. This machine learning is kind of relative new field, and many things are not written in the book yet. So you kind of need to read a lot of papers if you want to learn it.
Anybody else?
I'd like to add something to this. I wish I had taken some like algorithm, or data structures, algorithms course from computer science. That would have helped a lot, like in building my pipelines, like scaling my production models. So I think, yeah, that would have helped a lot. Yeah, like some courses from computer science in terms of like algorithms or system design, maybe. Yeah.
Yeah, and to piggyback off of that, for me, I would think I would have benefited from courses in like web design, app design, just being able to like build software products, because when you get out of programs like these, you have so much technical skill and you have so much ability to like build all the back end. If you just get the front end up and running, you have your own app and your own piece of business to build out.
Interesting. Okay, well then the final question. Deep learning is mainly based on gradient descent. How do you think we should analyze and understand deep learning?
Is this your question, Dr. Aktan?
No, actually, it's not mine. It's actually Lou's question.
Yeah, optimization is like it's one of the backbones of deep learning models. Well, I would say like one of the most important components of it, because yeah, there's this architecture, but how are you going to learn it? Well, through these optimization algorithms. Well, then there's this gradient descent, but the gradient descent is not being used as it is like the way that we are learning at school. Like there are different kind of like advanced optimization algorithms, which kind of like fundamentally rely on the gradient descent, but they are kind of like pushing the boundaries of optimization, like such as well, the very first one that comes to my mind is like stochastic gradient descent, and then comes the eta grad, and then comes the what was it, RMS pop, and then atom optimizer. So it's being like evolving, and it's not just like it's gradient descent and we just like keep using it. Yeah, they are fundamentally relying on the gradient descent, but they are proven to be working quite well. Yeah.
Yeah, I think that's a super hard question, how to understand this black box deep learning algorithms. There are a few attempts around different way. Actually, that's one of the challenges. We want to propose deep learning model to business team. They will always ask, can you explain this to me? And then one question or one direction we tend to do is use more interpretation tools. I say something called sharp value and some other things, but those tools are also suffer from this like association versus causality. So business team always ask for causality. I want to improve my revenue. Tell me, what should I do? And then from a scientific background, we cannot say for sure. Let's say if you do this, you will see this. Those are called, this is causal in fact, and counterfactual in fact, we cannot say for sure. But we are like moving towards that direction, trying to leverage A/B testing let's say we can test those hypotheses, we can form those hypotheses. And another way besides the interpretation tool and A/B testing is something more into the way of reinforcement learning. So you have a concept of somebody actively choose some action and then observe the feedback from the world. So those are the attempts, at least I'm doing, trying to answer this super hard question. But overall, we're still, I think I'm still in the early stage to answer this question. I don't have a very good answer right now.
One thing I'd like to add is this, the explainable AI has been kind of like very popular for the last couple of years. And the fundamentals of this explainable AI is boiling down to the gradients, basically. So if an input is having large gradients when doing the back propagation, or like when doing, like calculating the chain rules, basically. So it's going to contribute to the output, like that amount, or like that proportionate. So it is like we use, for instance, like in my current work, I try to like interpret the NLP models, and they are all like deep learning models. And I use gradients to see which words are contributing to the outcome the most, basically. So this is where the gradients or gradient descent comes quite handy.
I want to add that there's, at least in my opinion, there's two different things in, let's say, data science and statistics. And one is machine learning for forecasting, right? And you have your features, and then you can find out which are the features that are more important to your outcome. And then a different story is trying to do differential statistics, right? Trying to find out what is causing this, what is causing that, right? So for example, let's say you have two correlated variables and you put it in a machine learning as features, a machine learning application, let's say random forest. And then since the two are correlated, one is gonna have 0 importance and the other has large importance. And then you're gonna tell, if you don't understand exactly what's going on, you're gonna tell, oh, this is the most important variable to your outcome. But the reality is there's a philosophical problem of how is causality, right? You have to model interactions between all those variables. So I think it's a very tricky problem to handle, especially in machine learning. And I think it's important to know the difference between inferring which variables affect something and doing a forecasting or prediction.
I think you can start learning different kinds of optimization methods, like there's like Adam or a gradient descent with momentum. You will learn that in the traditional machine learning algorithm, we're trying to find the minimum point of some algorithm of a function. The function is usually very simple, and you can easily find the minimum point. If you're doing a deep learning, the surface usually like weird or unusual, and you are trying to use the optimization method to find those optimal point. You can try to start to learn like this way, but to be honest, I think most of the models in the industry are quite simple, except the NLP and the computer vision. One reason is that if you need to let it, let's say, run online, let's say you need to search something and then search something, Google something, and then Google need to respond immediately. The model cannot be too complicated.
Okay, well, thank you. And I think it's time to end our event. I want to thank again our panelists for being with us today. I want to thank our faculty, Dr. Burton, Dr. Needham, and I want to thank all the attendees. And if there are any students, graduate students, or students out there looking for a graduate program, and if you're interested in data science, please go visit our interdisciplinary degree in data science, our master's degree in data science.